Now we're going to use the CIE method for finding the inference of two means. Okay, a social worker is interested in comparing the nutritional levels of children from the inner city where she lives and children from the suburbs. She obtains the following independent random samples for daily caloric intake from children in the inner city and the suburbs. Assume both samples are taken from normal populations. Is the caloric intake of the inner city children less than the children in the suburbs? And we're going to test that with an alpha level of 0.10. So here's our chart. We have our samples. You notice that it's independent, and that's what they mentioned in the beginning. And one of the things we realize is that the inner city, they took 7 samples, where the suburbs, they took 6. So that's going to also tell us that it's not dependent. Therefore, our claim is that inner city, this is our mu sub 1 and this is our mu sub 2, is less than mu 2. So the inner is going to have less calories than the suburbs. Now, we can look here at our chart and kind of see that that's true, except for the third sample, but the rest of them are lower. And so we could say, well, yeah, just looking at that, but remember it has to be significantly lower, and we don't know if it is. So that's why we're doing the test. So our HO then, of course, has to have the equal part, and the opposite of less than is greater than or equal to. So our HA is our claim that inner city intake is less than suburbs. Our test criteria. Well, remember now we're doing a CIE, so we're doing a confidence interval. Our test criteria is alpha equals 0.10, but that would be for both sides. So for us, it's only 0.05 in our one tail, because this is alpha over 2. We have to divide it in half to find out how much it is for one tail. Okay, so now our degrees of freedom, we're going to need that later, is 7 minus 1 for the inner city is 6. Degrees of freedom for part 2 for the suburbs is 5. And remember, we're going to use the smaller one of the two since they're different. Okay, so creating our sample. We do need to know our standard error, that's our E. So we're going to need the standard deviation, and we already have our n's. And for a confidence interval, it's the difference of the means. Remember, this is the independent version. The difference in our means of our samples, plus or minus. Then here's our t-score with our alpha over 2, and the square root of, this is our error. This big thing is our E. So that's our E. So we need to find the mean of sample 1, and I've already done that, and if we added them up and divided by 7, we would get 1324.14 la la la. And normally you do not round these, but we're going to go ahead and do that to make the numbers better for us, which is 1324. For 2, we add up the suburban divided by 6, because there's only 6, and we get 1823. So now we have our x1 and we have our x2. I also went ahead and calculated our standard deviation, and that is 345.29 and so forth. Again, I've rounded to a whole number to make it, again, easier, and we get 345. Standard deviation 2 was 155.6, and I went ahead and rounded it to 156 because, again, this is causing it to go up 1. And then our N1 is 7, our N2 is 6. So we have all of our pieces of information except for our T. So that we need to look up in our table. So let's go ahead to our next screen and where we're going to do our calculations. So our E is, we took our 345, our standard deviation that we got, and squared it, divided it by 7. And then to that we added the 156 squared divided by 6, and that all became the square root of that value. 21,059 in pennies, I'll call it, even though it's not money. Well, once I square rooted that value, then I got 145.119 and so forth. So that's the value that we get for our E, which is here. So I brought that down into our formula. Our difference in our means, again, we took, let's go back, we can show. We took 1324 and subtracted 1823. Remember, it's always sample 1, subtract sample 2. So when we did that, we get negative 499 plus or minus our t for alpha over 2. Now, we're going to pull up our t table, and we're looking for the area in one tail, which is 0.05. Remember, our alpha level is for both sides, so we want 0.05. We're going to come down to degrees of freedom of 5 because we took our smallest n, which was 6, subtracted 1 is 5. We come over and we get 2.015. So that's our t for alpha over 2. So that's where we get this value. So there's our t. Okay, now if I multiply 2.015 and 145 and so forth, I get 292.175. Now, what I've done is, you're not supposed to do this, but I did it just for easy sake, is I took off, so I rounded, and now I have a negative 499 plus or minus 292. So our CIE, if we subtract, we get 791. If we added it because it's positive, we get 206. Now, remember, these are zeros. These are less than 0. These are negative values. So what it's saying is our true population mean, if we subtracted those, so the mean, the true population mean for 1 and the true population mean for 2, if we subtracted those, it should be within this interval for us to accept HO. That's what we're saying. Well, since the interval has not captured the true population mean, and why? Well, remember, we always want to assume it to be 0. We want the true population means to be the same. That's what we always assume. So this should be a 0. Well, that does not fall in that range. Zeros, if you look at the number line this way, 0's over here somewhere. Here's negative 1, negative 791, and here's negative 206. So somewhere here is our interval, and here's 0. So it did not capture it, so we can reject HO. It's outside of our interval, so it's going to fall into that rejection region. So our decision is to reject HO. If we go back and we look at what was our HO, it was not our claim. So if we are rejecting HO, that's what we reject, then we accept our claim is that the inner city children do have a smaller caloric intake. So let's go back. So there is enough evidence to support the claim that the inner city children have a lower calorie intake than the children in the suburbs. And that's the end of our example.